800 people with one mission, promoting a healthy environment. We are the West Virginia Department of Environmental Protection.
The Federal Railroad Administration has determined the cause of a fiery accident involving a CSX train hauling crude oil last February that forced hundreds of residents in the Mount Carbon area from their homes for days.
And investigators say it could have been prevented. The derailment was caused by a broken rail. According to the FRA report, over the course of the weeks and months leading up to the accident, one of the rails developed a flaw that's known as a vertical split head. That's a crack along the length of the upper part of the rail, the part that supports and guides the wheels of railroad cars. When it failed, 27 fully loaded tank cars jumped the tracks. 2 of those cars were punctured, causing them to leak oil, which ignited and spread quickly to the other cars. The intense heat from the ensuing fire led to thermal tears in 13 additional cars. In all, the accident released 378,000 gallons of crude oil, most of which either burned off or soaked into the ground. The fire also destroyed a home and a garage. Investigators say tests by Sperry Rail Service, a contractor hired by CSX to detect rail flaws along that section of track, showed evidence of the flaw on 2 occasions prior to the incident. They say in mid-December, the contractor's test equipment showed indications of the flaw at the eventual point of the derailment. Another test performed in January found a similar but more significant flaw at the same location. The equipment operator told investigators that he assumed the positive tests were the result of rough rail service conditions and not a structural flaw, which is why he didn't conduct a required visual inspection. Investigators say the presence of the vertical split head flaw was the prime factor causing the loss of structural integrity of the rail. The Federal Railroad Administration has recommended additional training for operators of rail flaw detector cars and continued use of improved technology that compares previous inspection data with data collected in real time so that operators can more accurately identify areas that should be hand tested and increase the likelihood of detecting rail flaws. The FRA also recommended that CSX establish a plan to identify and replace track with similar flaws on high-hazard flammable train routes. Work began in earnest this summer on an ambitious project designed to give scientists an unprecedented look into a Marcellus gas drilling operation.
The Marcellus Shale Energy and Environment Lab is designed to develop and validate new knowledge and technology to improve efficiency and minimize environmental implications of horizontal drilling and fracking natural gas wells. This may look like a typical gas drilling operation, like any other located throughout the Marcellus and Utica Shale formations, but this well pad just outside downtown Morgantown is different. Besides producing natural gas, it's already producing data, lots of data.
In terms of the growth of the industry and the technologies that have been employed and the environmental issues that we're dealing with, they really haven't been studied in a detailed way at a particular well site. And that's important because a lot of the studies that you see in the published literature, I'm speaking as a scientist here, are little bits and pieces from different well sites, different sources of water, for example, different sources of waste streams, at different stages during development. So we haven't had a really continuous flow of data.
And that's what makes the project unique. Previous studies have combined data from different well sites in different locations at different times during the process to try and form a big coherent picture of the whole process.
Now that has the advantage of having a broad regional distribution in your data set, but it has the weakness of not having a continuous source of data. And the reason that's important is that when we looked at this, the whole issue of what's coming out of shale gas, and we've been working on this subject for better than 5 years now through various projects, we would look at the literature and say, tell us what you know about flowback water chemistry. And we'd get one set of readings and go to another paper and find out that the data were all over the place. So just by looking at it, taking little snapshots of wells here and there, you could get the impression that this is a very that individual wells are producing very different kinds of waters, and in reality, the water chemistry is fairly similar. It just changes at a given well over time.
Getting and keeping that flow of information is critical to the success of the study.
It's been very difficult to get all of the kinds of information on the process that we really need to do the good science to match up the field data with the process data. And so in this particular case, we have a driller that's, besides being very cooperative, knows that the purpose of this project, in fact, is to get this information and share the information. It's very expensive to do it, and to have the opportunity and to be in on that opportunity is really groundbreaking and really important for science and for the people that science serves.
But this is also a business operation, and as with all other businesses, time is money.
They're going to have these wells on by November 1. That's why this is sort of this data acquisition part of this project is really, really fast. And it has to be. That rig costs $3,200 an hour. So they don't want to wait around for us to do science, okay? We have to be moving when they're moving.
Work on the top hole drilling began in late June on 3 wells, each more than a mile deep. 2 are for production, the third is strictly for science.
A lot of questions on the impact of these things, these Marcellus wells. They are big wells, no question about it. And so we're documenting all the air, the water, the noise, the economic impact of these as far as the direct employment. This partnership is important on all kinds of levels, because this is shale gas and shale oil is what's powering this country, and is what's going to power the world for the next 50 years.
The Marcellus Shale Energy and Environmental Lab is a joint project of WVU, The Ohio State University, the U.S. Department of Energy, and Northeast Natural Energy. Up next, getting together with youth groups from all across the state is an annual fall tradition for the DEP's Youth Environmental Program.
We'll tag along to this year's Youth Environmental Conference.